back to 9.4. We're talking about electric circuits. Specifically, what components are part of a circuit, how to draw that type of circuit, and then two different categories of circuits that we're going to be looking at a little bit further. So first, an electrical circuit is a pathway through which current can flow. So it's just providing a place, a direction that the current or those charges can flow through. So we've actually made a lot of circuits already in class, but they're typically made of, you might say wires, you might say different types of metal, different types of conductors, some type of power supply. Those things would all be right, but let's just take it a step further. Let's just talk about what types of things have or contain electric circuits. These can be any number of things. There are so many things you use every day that have circuits. For example, your phones, motors, toasters, lights, all those things have circuits, and maybe some of them look kind of like this nice circuit board you see in this picture. But if I want to represent circuits in a way that I can draw them, I want to represent a circuit diagram, we call it, or in other words, a schematic. I want to be able to represent the typical objects that would appear in a circuit using just my pencil and paper. And so that's actually what you'll see in your reference table in this table. And there's a key that says what each component would look like if I were to draw it. So someone reading your paper can see what type of circuit you would like to make. So before we can even talk too much about that, we've got to look specifically at our voltmeters and our ammeters and what each of them do. So you guys know a voltmeter measures the electric potential in a portion of the circuit, but there's a specific way we hook it up, and we're going to call it hooked up parallel to the circuit components. So what's that look like? I'm going to start drawing this diagram first. We'll go back to the Y. That looks like if you've got this simple circuit, you'll notice according to my schematic, I've added a resistor and I've added a battery or a power source in my circuit, just a simple circuit. Now if I want to measure the voltage, the potential difference, I've got to hook up my voltmeter. For example, if I want to measure it from A to B over our resistor, I would hook up my voltmeter in parallel to that component. So component 1, my voltmeter right there. Those are in parallel to each other. Well, why would I do that? Well, the reason is a voltmeter I'm using to measure the potential difference across the component. In this case, I'm measuring it across the resistor. The reason why I have to put it in parallel like this is because this component must not interfere with the path of the current or the circuit, with the path of the circuit. And sorry if that's a little messy. But what I don't want to do is interfere with the flow of the charges. They're still going to flow normally as they do within our circuit. The voltmeter is an additional component that will then measure the change across our resistor. The other component we're going to talk about is the ammeter, which we've got here. We're going to represent it with a little A in a circle. And the ammeter is going to measure the current flowing. It's a measure of current. And we know that the thing that's actually carrying the current is our charges moving through the circuit. So in order to measure that, we actually want the charges to go through our ammeter because we want to see how many charges are flowing in a specific amount of time. That's our current. Is the change in Q or charge over time. So in order to do that, we actually have to hook up the ammeter in what's called series. That means it actually has to become a part of our circuit because we want to count each electron that's passing through our ammeter. So let's draw another diagram. Here's your battery. And again, a simple diagram. I'm hooking it up to the resistor, as you see here. Now, I want to measure current at a specific point. So, for example, I might want to measure at point A, as opposed to the potential difference or the voltage I measure across between 2 points. Current is measured at a single point. If I want to measure it here, the ammeter must see, and this is the line, the ammeter must see each electron that passes through. Each electron that passes through our circuit, or each path. So when I draw my diagram, I want to measure the current at point A. What I have to do is break apart this circuit so my ammeter can measure all of the charges that are going to go through the circuit. Therefore, when the charges go through our wires, they cannot resist going through the ammeter. They have to go through, therefore it can measure the current. So that's ammeters and voltmeters. We're going to be using it a lot to measure current and voltage in the circuit. But let's look at a couple examples. So if I want to draw a circuit that has two 50 ohm light bulbs and a 120 volt power source, I'm going to use the key on my reference table. I know my power source is my battery, it looks something like that. I'm going to label it with 120 volts. I'm going to connect this circuit, I'm going to do it in series, meaning there's a single path for the charges to go through. I'm going to go through one light bulb, I'm going to go through another light bulb, and end up back at my battery supply. There's the glass around their light bulbs. I'm going to label these as each 50 ohms, and this is a series circuit because there's one path. Now let's add another layer of difficulty here. I want to draw another circuit now with three 8 ohm light bulbs, 120 volt power source, and a switch. So the first thing I want to do is just draw my nice little power supply. I'm going to give it a path. I'm going to provide a switch. And I'm going to have 3 light bulbs. 1, 2, 3, and come back up. Put some glass around these. We're going to label each one. Now first of all, this is hooked up in series, but the directions also want an ammeter to measure the current in the circuit and a voltmeter to measure the potential difference across each light bulb. So let's add our voltmeter first. We measure it in parallel. We're going to add it in parallel. So if this is the light bulb I want to measure, I'm going to add a nice voltmeter like that from one end of the light bulb to the other. I'm going to do the same thing with the next light bulb, and the same thing with our last light bulb. Then if I want to use the ammeter to measure current at a specific point in the circuit, I've actually got to make a break in the circuit, add my ammeter right into the circuit so it is in series, and the current's going to flow right through it. That is a series circuit with the components you see here. For the next circuit, it's the exact same instructions for the most part, but what I want to do is draw this one in parallel, so you can kind of see what a setup would look like. So we're going to draw this one in parallel, and we want a 10 ohm resistor, 50 ohm resistor, 70 ohm light bulb, and a 240 volt power source. So first thing, I'm going to set up my power source, going to set up my circuit. We're going through a 10 ohm resistor, a 50 ohm resistor, a 70 ohm light bulb, and back to the start. I'm going to label each component. And I've got my circuit. I'm sorry, this one's in series. I'll do the parallel one in a second. So I've got my circuit. We're going to add an ammeter to measure current. Again, make a little break. Put your ammeter right into the circuit. And if I want to measure volts across each light bulb, again, here's my light bulb. There's my voltage in parallel. Well, now what if I wanted to build this circuit in series? I would do the exact same process, set up my light bulb, or set up my battery, but now if I want to do this in parallel, I want each component to be its separate pathway. So the current could choose to go through this pathway and that resistor, or it could choose to go through this resistor, or it could choose to go through a third pathway with a light bulb. We call this in parallel because these are all parallel lines to each other, and the current could choose to go through this pathway, or this pathway. If I want to measure the current in the entire circuit, I have to measure it where every pathway is going to converge. So that would be about here. Every piece of current has to go through this ammeter before they're going to split into different paths. So that's why I measure the ammeter there. That's my whole circuit. And if I want to measure the volts across the light bulb, I attach another voltmeter in parallel, and I get that. This is the last example. I want you to try it. I want you to try it on your own. I guess it is not here. I'll give you a couple tips. For that last example, draw that 10 ohm resistor, 50 ohm resistor, 70 ohm light bulb. So we're going to do this. And I want you to just put that in series. Make sure you add a voltmeter and an ammeter into your circuit. Do it on your own, then you can check my answer. So I've got a voltmeter, I've got 2 bulbs, and a resistor. And remember that the order I put these in does not matter as long as I put each component in here. I'm going to label 120 volts, 10 ohms, 10 ohms, and 25 ohms. And I measure the voltage over each component, put it in parallel, and I can measure our ammeter anywhere in our circuit to find the total current, break it apart, add an ammeter, and you're good to go. Thanks for watching.